Hello everybody, I welcomes all of you to this lecture. I hope you have seen my previous video lecture in which we have covered basics of state space model of any system. What do you mean by state space model? How to write equations? What do you mean by state variables, state vector? All other things are covered in that lecture. Okay, so I request all of you, please see that video, then only you will understand the next parts, because basics are very important. If you understand what do you mean by the equations and why they are used here and what do you mean by A, B, C, D, then only you can understand this lectures part. Okay, so that's why it is mandatory to see that lecture. I hope everyone has seen that. Okay, so this is the last unit, and in this lecture we have to cover two most important points named as observability and controllability. Okay, so I hope you have seen this previous lecture. Let's see this basics about the state space model, and then we will start with next new points. Okay, so again let's revise that in one slide. The state space model of a linear time invariant or LTI system can be represented as x dot is equal to ax plus bu and y is equal to cx plus du. Okay, now here the first and second equations are known as the state equation. Okay, so these two are the, we can say, related to state space model. The first equation is known as state equation, and the second equation is known as a output equation. Okay, so if you see, this is a state equation, x dot is equal to ax plus bu, and output equation is denoted by y, which is equal to cx plus du. And I think you are aware about a, b, c and d. So let's see that what is this. X and x dot are the state vector and the differential state vector respectively. So if you see the x is generally denoted by x state vector. Okay, and if you see the x dot, it is the differential state vector. Okay, so this is the relation in between this x and x dot. I think you know how to differentiate that and how this dot is denoted, why this dot is denoted here. Okay, then if you see, u and y are the input vector and output vector respectively. So if you see u is the input vector which is given over here, and y is the output vector. Okay, so A is called as a system matrix. It is generally, A is generally matrix, and that is called as a system matrix. Similarly, if you see B and C, these are the input and output matrices. So if you see, B is the input matrices, C is a output matrices, and D is generally called as a feed forward matrix. Okay, again please keep these things in your mind. This is very important. These two equations are nothing but your state space models equation. Again I am revising this for your better understanding. This is called as a state equation. X dot is equal to ax plus bu. Okay, so in this case x is a state vector, x dot is a differential state vector. Similarly, if you see y is equal to cx plus du, where y is nothing but your output equation. Okay, and in this case, if you see u and y are the input and output vector respectively. So here u is the input vector, y is the output vector. Okay, so A is a system matrix, it is denoted by the A system matrix. B and C are the input and output matrices, and lastly D is a feed forward matrix. Okay, so these all other things are covered in previous lecture. Okay, so this is just for your introduction to start with the new point. Now let's move forward. Let us see what do you mean by controllability. Okay, now a control system is said to be controllable. Listen carefully. A control system is said to be controllable if the initial state of the control system are transferred or changed to some other desired state by a controlled input in a finite duration of a time. So such system is called as a controllable system or controllability of the system. So let us understand the meaning of this. Okay, suppose you have given a finite duration of a time. Okay, so you have to see the functionality of the system for finite duration of a time. Okay, so means what? There is a considerable time, and a control system is said to be controllable if you convert your initial state of that system into some desired state. Okay, with the help of some controlled inputs. Means what? Suppose you have some control input, set of inputs, and if you able to control the state of the system from initial state to the your desired or required state in given finite duration of a time, then that property of the system is called as a controllability. Okay, now how to check the system is controllable or not? Okay, so for that purpose, of course we have to see one example. Before solving that example, we must know how to solve that example or which rule should be used. Okay, so we can check the controllability of a control system by using Kalman's state test. Okay, so if you see the Kalman's tests, we have to use this test to check the system's controllability. Okay, let us see that. Now write the matrix QC. C is for controllability in the form given as below or in the following form. So it is given by QC is equal to, so in bracket B, then AB, then A square B dot 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 up to A raised to n minus 1 into B. Okay, so this is again matrix type. Okay, matrix form. Okay, now what we have to do is that we have to find this QC first. Okay, with the help of B and A, and find the determinant of a matrix QC, and if it is not equal to 0, then the control system is controllable. Now see this carefully. Again I am explaining you the procedure. We have to obtain B and AB with the help of the equations given over here like this. The equation will be like this. We have to convert that equation into our required form, and then we have to find out B matrix and A matrix. Then we have to find QC with the help of that. For that you have to use this formula or this equation, we can say. After that we have to find the determinant of a matrix QC. Okay, so I will explain how to find the determinant. And if that QC is not equal to 0, means it is non-zero value, then the control system is controllable. And if that QC becomes equal to 0, then such a system is called as a non-controllable system. Okay, so let's see with one example. So this example is given over here. The x dot is given and y is given. So let us verify the controllability of a control system, which is represented in the state space model as. So this is the real example of a state space equation or a state space model. X dot is given, y is given over here. So generally you know that x dot is nothing but x dot 1 and x dot 2. It is matrix. Okay, and these are the terms in that x dot. So now we have to convert this x dot and y, we have to compare this x dot and y with these standard equations. Okay, so then only you will get the value of A matrix and B matrix, similarly C and D matrix. Okay, so I think you got the idea about this. So let us find which is A, which is B, which is C and which is D. Now if you see here, if you compare this equations given with the standard equation, then you will get the value something like this. So A will be nothing but this matrix, that is -1 -1 1 0. Let us compare this. So if you see, this is your A, this is your X, this is your B, and this is your U. Okay, see here, this B is 1 0, so this B is a 1 0. Okay, I think you got this. This is A X plus B U. So A is this one and B is this one. So we got these two matrix which are required for calculation of a QC. Okay, now again there is no need to see this C and D, but let's see that with the help of this equation. C is nothing but your 0 1, although it is not given here, but this is C is equal to 0 1, and there is no D in this equation, so D will be equal to 0. Okay, and we have to find out N. N is very important in this equation because it will be helpful for calculating QC. Why? Because as per this Kalman's test, QC is equal to this equation, that is B, then AB, then A square B, okay, dot 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 up to A raised to N minus 1 B. So here we have to find the value of N because N is given in this equation, but how to find the value of N? So if you see the value of N, this is with respect to this matrix A, because if you see this matrix, it will be denoted by M into N. Okay, so here N will be 2. Okay, if you see this, the N will be 2 because this is a 2 by 2 matrix. A is a 2 by 2 matrix, so it can be represented by M into N matrix. So N will be here, again M will be 2 as well as N will be 2. Okay, so that's why we got the value of N as a 2. Now if you put the value of 2 value of N as a 2 in this equation, this will be limited to up to if you see A raised to 2 minus 1, that is 1, means this will be limited to this first two elements only. Okay, please see this carefully. Okay, so I am going to explain this example in very simple way, and based upon this example you have to try other example also. Okay, so it is not possible to cover each and every type of example in this lecture, probably in online mode. Okay, so that's why you have to see this example carefully. I will guide you regarding this, and then based upon this only you have to solve another examples. Okay, I will give just idea because we don't have much time. So again I am repeating, the value of N is 2. So here A raised to 2 minus 1 means A raised to 1 into B, so means first two term will be there only, so B and AB. So that's why our QC will be equal to in matrix form B and AB because N is 2 here. Suppose N is 3, then what will happen? This will be A raised to 3 minus 1 means A raised to 2B, so it will be first 3 columns of this matrix, we can say. Okay, so like it will be there, but here value of N is 2, so that's why we have got only 2 values. We have to get only 2 values, that is very important. So the QC is equal to B AB. Okay, so now if you solve this B and AB, B is already there is no need to calculate, just we have to calculate AB, means multiplication of this matrix with this one, and then we have to put the values of B and AB into this matrix, and then just we have to calculate this we can say whatever we have determined earlier, that is determinant of this matrix, and then we have to check with this equality to 0. Okay, so let's solve this. B is already there, that is 1 0. Let's solve A into B. So A into B means what? Multiplication of this into this. So I think you know how to multiply the matrix. This is very basic thing. See how to multiply. We have to multiply this first row with this column, then multiply this second row with this column. Okay, now if you want to multiply this row to this column, this minus 1 should be multiplied with this 1, plus this minus 1 should be multiplied to this 0. Similarly here also this 1 should be multiplied with this 1 plus this 0 with 0. So let's solve this. If you see this first row and this first column, only one column is there, so first row and column multiplication, here minus 1 into 1, it will be minus 1, and again if you see this and this becomes 0, minus 1 into 0 becomes 0, so only first term will be what? Minus 1. Okay, in first term in AB column will be AB matrix will be minus 1. Similarly, if you multiply this with this one, so it will become 1 into 1 1, then this 0 into 0 0, then it will be again only 1. So the AB will be what? Minus 1 and 1. I think you got this. Please see carefully how to multiply the matrix. I think you know this. This is the basic mathematics. You may have studied this previously. Okay, just brush up your knowledge. Now we have to put this B and AB. So B is 1 0, so it is put over here 1 0, and here we have to put matrix of AB. So AB is minus 1 1, so it is put over here. Now we have to find out the determinant of a QC. So before that we have to find the value of a QC, and determinant is written like this. Okay, again you must know how to get the value of this matrix. I think you know this very well. So you have to multiply this with this one, 1 into 1 minus 0 into minus 1, so it will be 1. See, again I am repeating this, you have to multiply with this to this, 1 into 1 minus this 0 into minus 1, so 0 into anything will be 0, so the value will be only 1, and the determinant is nothing but your this value is 1, which is not equal to 0. Okay, so as per rule, whatever we have seen, if you see the determinant of matrix QC, and if it is not equal to 0, then the control system is controllable. So as per our rule, if you compare this, it is not equal to 0. So since the determinant of matrix QC is not equal to 0, the given control system is controllable. So this is the conclusion. So in this way we can find the controllability of the control system. Okay, so I think you got the idea behind this. Just don't stop over here, because you have to solve number of varieties of example. So based upon this idea you can solve multiple examples now. Okay, so just try that with the help of some standard books. Okay, now let us see the next important point, that is observability. Okay, so here the definition is like this: a control system is said to be observable if it is able to determine the initial state of a control system by observing the outputs in finite duration of a time. So see just what is the reverse in definition of observability and controllability. Okay, so just carefully see this. Again I am repeating, a control system is said to be observable if it is able to determine the initial state of a control system by observing the outputs in a finite duration of a time. Suppose you have given the outputs of any control system for a finite duration time. If you observe that, and if you able to get some initial states of that same control system, then that type of a system or control system can be called as a observable control system, or it will be having a observability. Okay, again this is again very easy and similar kind of a method to find this system's observability. Okay, so we can check the observability of the control system by using again Kalman's test. Okay, so let us see how to solve this. Again, what we have to do is that we have to write the matrix in the form of a QO. So O is for observability. Okay, so see, previously we have seen QC. So if you see this C, small c, this is for controllability, and here this O is for observability. So we have to find here QO, which is nothing but set of this CT, AT, then CT, then next will be AT into CT, then AT square into CT square, up to AT raised to n minus 1 into CT. Okay, again here this T is coming over here, so I think you know about this. Okay, see this equation carefully. Again I am repeating, Q naught is equal to CT, then second term is AT/CT, then AT square into CT, then up to it will be AT and raised to n minus 1 into CT. Okay, so this is nothing but different type of a matrix. I think you have studied this. Now what we have to do is that we have to find the determinant of a matrix Q out, and if it is not equal to 0, then control system is what we can say observable. Okay, so I think you know this. This is called as T is nothing but transpose matrix. Okay, So, and I think you are aware about how to convert a matrix into its transpose matrix. Okay, if you able to convert that into a transpose matrix, then your, we can say, procedure will be similar to last example, like a last example. Okay, so let us see the same example. Now let us verify the observability of a control system which is represented in the state space model like this. Okay, so same example we have taken for your better understanding. Okay, so previously we have seen this system is having controllability. Let's see, is it having observability or not. Okay, now here again, if you see, the same example is given. X dot is equal to, it is matrix, you know, x dot 1, x dot 2 is equal to, this is the first matrix, that is A, minus 1 minus 1 1 0 into x, that is x1 x2, plus there is a B, that is 1 0 into u, and y is given as only this, we can say 0 1 and x1, means only c term is there, d term is not there, so that's why d can be represented as 0. So here this is A, this is B, this is C, and D is 0. Okay, because it is not given, but in different examples there may be a value of D, but we are not interested in that value. Now here, as I discussed earlier, A is equal to minus 1 minus 1 1 0, this matrix, B is 1 0, then C is 0 1, this is C. Okay, please correct in your notes, means just write C is equal to 0 1 or like this. Okay, D is equal to 0, D is not there, and N is equal to again 2. Okay, now first thing that we have to do is that we have to convert this required matrix into its transpose. Means what? We require C and A. Okay, so we are not interested in B, we are interested in C and A, and we have to find the transpose of this. So we have to convert this A into transpose matrix of a means AT. Similarly, we have to convert this C matrix into transpose of C, that is a CT. So let's convert this first one, that is A into AT. Means what? We have to just convert the rows to column and columns to rows, that will be a transpose matrix. So let us see that. See here, if you see this A, this minus 1 and minus 1 is a row here, and here if you see, this becomes column, first column. Similarly, if you see second row, that is 1 0, it will become a second column. So rows becomes column, we can say. So AT is derived from this A. Similarly, if you see this C, it is having row, it will be converted into one column in its transpose form. So CT is equal to 0 1. Okay, now again, as per our formula, N is equal to 2. Let us put that N is equal to 2 in this equation. So it will become AT raised to 2 minus 1, that is 1 into CT. So again, it will be restricted to only two terms, that is CT, and second term is AT CT. Okay, and we have to find the matrix of that. Now we have to calculate this only, and after that we have to find the determinant of the matrix, and after that our job will be simple. So here, if you see, Q out is equal to CT into AT CT, and second term is AT into CT. Okay, so CT is there already, we have converted that. Let's find AT CT. Okay, means what? We have to multiply this matrix with this one. Now here, let us multiply this. This is multiplied, this first row is multiplied to this column, and then for second term, this second row is multiplied to this column. So let us multiply this. Minus 1 into 0, that will be 0, then 1 into 1. Okay, so if you see here, it is added, so it will be 1. Again I am repeating, minus 1 into 0, it will be 0, plus 1 into 1, so it will be here, it will be 1. Okay, now for second term, let us multiply this. Minus 1 into 0, that is 0, plus 0 into 1, that is again 0. So 0 plus 0, it will be 0. Okay, so we have got this one, that is AT CT. We have already CT, So let's put CT in this, let's put this value of the CT over here, value of AT CT over here. So here we are getting 0 1, that is this CT, and value of this AT CT will be what? This one 1 0. So it is put over here. Now again, you know how to find the determinant of the matrix. Let's find out value of this matrix first, and then if you see this symbol, this will be helpful for finding the determinant. Okay, so this 0 into 0, that is 0, minus this 1 into 1. So 0 minus 1 will become minus 1. Okay, although it is minus, it is not equal to 0. See carefully, as per the definition, if the determinant of this matrix is not equal to 0, then the control system is observable. Therefore, if you see here, since the determinant of a matrix Q out is not equal to 0, means it is equal to minus 1, so it is not equal to 0, means it is non-zero value again. So the given control system is observable. So in this way we can find out controllability and observability of any control system. Okay, so system at the same time, the same system may be observable and controllable. Okay, based upon the value of QC and Q0, you will get the system is observable or controllable. Okay, and I think the procedure is very simple that I have explained, and that should be applied to each and every example. So some examples may be complex, but I have given you much idea about this. So with the help of this you can solve. Okay, so please see that controllability and that observability. The control, again I'm giving you a difference between this. This controllability means what? If the initial states of a control system can be transferred to desired state for given finite duration of a time, then the system can be called as a controllable, and that is denoted by QC. Okay, so you have to take this simple matrix BAB, and then A square be like this. Just see the value of n. N is nothing but this matrix, rows, columns, or m by n we can say, and from this you can get the value of n. This is very simple, and after that it is not equal to 0, then system is controllable. But in case of observability, it is slightly, we can say, different. Means what? A control system is said to be observable if it is able to determine the initial states of a control system by observing the outputs in a finite duration of a time. Again, same Kalman test should be applied, but with respect to C and AC in a transpose form. So how to find a transpose of any matrix, that also I have explained over here. And again, if you see here, if it is not equal to 0 as per the definition of this, then the control system is observable. Okay, so same example we have taken because it will be very easy to understand you how to solve any example. So same example we have taken, and we have concluded that the given example is observable at a time, controllable. Okay, so this is denoted like this. So this is all about the most important properties of a control system, that is observability and controllability. Okay, so I think this much is sufficient for this lecture. Okay, so I may share some nice videos with you for the understanding of the these concepts and example if possible. Okay, so today this will be sufficient. Thank you very much. Just prepare well. Okay, best of luck.